right, so today we are going to talk about, they're called combined inequalities, okay? So basically a combined inequality, it's two inequalities combined into one, okay? So there's two ways that you can combine an inequality. One is with the word and one is with the word or. I used to try to come up with different ways to kind of help you understand the difference between the and the or. I think it comes kind of semi-naturally, but I saw this and I thought it was wonderful, okay? So whenever we're doing this, I want you to think about an intersection of roads. Okay, so we are really, really close to Central and Tyler. Okay? So, whenever we talk about what's called a conjunction, which is an and inequality, this is whenever you take two inequalities and you put the word and in between them. The solution to this inequality is the solution that works for both inequalities. Okay, it has to be a solution for both. So if you think about your roadmap here, okay, this would be like saying, what are the businesses, the places, and there's not houses, okay, but what are the places that are on both Central and Tyler? Okay, well, if you think about this, I mean, nothing east of Tyler, nothing west of Tyler on Central, nothing north of Central or south of Central. The only things that are on both Central and Tyler are at this intersection right here, right? So it'd be like there's like a Legacy Bank there, there's your Jimmy's Egg, there's like a car dealership kind of thing right there, and then there's one fast Wendy's, okay? Anything else is either on Tyler or it's on Central, okay? But the only things that are on both Central and Tyler, okay, are going to be anything, okay, that are on one of those four corners there. Or I guess technically if you wanted to establish a business right in the middle of Central and Tyler, that would work too. But I mean, or I guess if you're talking about driving your car, right? You're either driving on Central or you're driving on Tyler unless you are going through the intersection. And at that point in time, you are on both Central and Tyler. Okay, does that make sense? Now, with an inequality, these are, I would say, probably the more difficult of the two to solve just because they look differently. Because you're not, most of the time, actually going to see that word and. Okay? Most of the time, these are going to look like this. Okay? They're going to say like, negative 4 is less than r minus 5 is less than or equal to negative 1. Now, kind of at first glance, it might seem like this is just one inequality, but if you look closely, there's two inequality symbols. See that? There's two inequalities here. So the first thing you have to do, and this is really the only difficult thing I think about this, is you have to separate it into those two separate inequalities. So to do that, what you're going to do is you're going to cover up that right inequality symbol and anything to the right of it. That right there, that negative 4 is less than r minus 5, that's one of your inequalities. Negative 4 is less than r minus 5. That's one of them. Okay? To get the other one, you're going to cover up the left-hand inequality and anything to the left of it. So that second inequality is r minus 5 is less than or equal to negative 1. Okay? And then we can put the word and in between them. Okay? And then, I mean, really to solve this, you're just going to solve both of them. So this first one, to solve for r, we would add 5. Negative 4 plus 5 is 1, is less than r. Now, the best way to write your answer, remember we talked about this yesterday, we are going to flip it around and say r is greater than 1, and, okay, then to solve this one, we would add 5, and we'd have r is less than or equal to negative 1 plus 5 would give me 4. Now, this is your answer, r is less than 1, and r is less than or equal to 4. Now, we didn't graph yesterday because they were just multi-step inequalities. We are going to graph today. And these are a little bit different to graph, okay? First of all, we're still using a number line, okay? You can show me where 0 is, but I don't necessarily need to see where 0 is. What I need to see is where these two numbers are. So I've got 1 and I've got 4. Okay? Now you're going to have two dots because you have two inequalities. The first dot at 1, see how it's a greater than? Since it's just a greater than, not an equal to, we're going to use an open dot at 1. And then at 4, since it's a less than or equal to, 4 is part of my answer solution, so we're going to use a closed dot. Now, when you're trying to decide where you're going to shade, okay, remember, you can't be on both Central and Tyler unless you're at the intersection of Central and Tyler, okay? So what you're looking for here is kind of like the intersection of these two inequalities, okay? So what I like to do is I like to take the first one, and I'm not necessarily going to shade it, but if r is greater than 1, this inequality would be shaded to the right, okay? And then r is less than or equal to 4, that inequality would be shaded to the left. What I'm looking for is the intersection of these two inequalities, which would be this one right here. The area that they have in common. It has to be the numbers that work for both. So that would be the graph for that one. Okay? Questions on that? Now, the easier way, I think, okay, is if you have a disjunction, which is an or inequality. So if you throw the word or in between them. So this would be like saying, okay, I'm on Central or I'm on Tyler. Now here's the thing. If you're on Central or you're on Tyler, well, I could be on Central or I could be on Tyler. There's a lot of options there, right? You shade all of Central, right? Because as long as you're on Central, that would work, right? Or, if you're not on Central, as long as you're on Tyler, that works. Now, if you're like at Maple and Mays, yeah, that doesn't work, right? But as long as you're on Central or you're on Tyler, so you would shade all of Central, you would shade all of Tyler. Okay, does that make sense? So the or inequalities are really easy because you just have to find the numbers that work for one of the inequalities. You can be on Central or on Tyler. You can find a number that works for this inequality or this inequality. It doesn't matter which one. As long as the number works for one or the other, no problem. So this one might look like 4v plus 3 is less than -5, or negative 2v plus 7 is less than 1. So this one, we just solve each one of these, okay? So if I start with this one right here, we could subtract 3. I'm going to jump down below here. 4v is less than -8. Divide by 4. So we have v is less than -2. All of the numbers less than -2 would be part of this solution set, okay? Or if they're not less than -2, okay, maybe they're in this inequality. So if I subtract 7, -2v is less than -6. That's divide by -2. Divide by negative. Flip the sign, so v is greater than 3. So your answer, v has to be less than -2, or it has to be greater than 3. Now remember, when we shaded our streets, I shaded all of Central and I shaded all of Tyler, because I said you could be on Central or Tyler, okay? So for this one, these are super easy to graph, because here's the thing. Any number that's less than -2, so -2, since it's just less than, it's going to be an open dot, and I shade to the left. Any one of those numbers works because it's a solution to that first inequality. It just has to work for one or the other, okay? Or if it's not in that shaded area, it could be greater than 3. So I'd have an open dot at 3, shaded to the right. It could be any one of those numbers, okay? So anything to the left of -2 or anything to the right of 3 works. Now, anything in the middle here, those numbers won't work. The outside the numbers will, okay? Questions on that? Okay, let's get this flute in. Should be on page 29. And these are called combined inequalities. Combined inequalities. Okay, so we are going to solve and graph these today. So we'll take the first few. Pretty slow here. Okay, number one. Number one says 5 is less than k minus 2 is less than 11. So the first thing I like to ask myself is I like to kind of prepare myself, is it an and or is it an or? The ors are really easy to pick out because you see the word or, and the ands you'll sometimes see and, but most of the time you won't, like this one. I don't see the word and. You cannot squash an or together. It's not possible. Okay, it will not read correctly. You can try, and you can probably come up with something that looks right, but mathematically it is not correct. Okay, so if it's ever squashed together, you know it's an and. So if you know it's an and, the first thing you need to do is break it apart to the two inequalities that you see. Okay, so the first one, you're going to cover up that right-hand inequality symbol and the number to the right. That's your first inequality right here. 5 is less than k minus 2. That's one of them. Okay, the other one, you're going to cover up that left inequality and the number to the left of it. So the 5 is less than, cover that up. That's your second inequality right there. K minus 2 is less than 11. And then once you write down your two inequalities, you just solve both of them. And this is an easy one to solve. If I add 2, we have 7 is less than k. Would be better to flip this around and say k is greater than 7. And the second one, we add 2 and we have k is less than 13. Okay, now that's your answer, but we want to graph our answer. I need to graph all of the numbers that are greater than 7 and less than 13. So think about Central and Tyler, that's just the intersection, right? Central and Tyler is just the intersection. So when I graph this, I can go ahead and mark 7 and 13. At both 7 and 13, neither one of those are equal to, so both of these are going to be open dots. But I only want to shade the area that both of these inequalities have. So if I have k is greater than 7, well, that's all the numbers to the right of 7. Even going beyond 13, right? Those are all the numbers greater than 7. But the numbers that are less than 13 are all the numbers to the left of 13. Now, all of those numbers go beyond 7, but the problem is, if I only want the numbers that work for both, I can't go to the left of 7, because it doesn't work for the first inequality. I can't go to the right of 13, because it doesn't work for that inequality. The only numbers that work is the intersection, the place that they overlap, which would be there in the middle. Okay. Number 2. So we have 9 minus c is less than or equal to 2, or negative 3c is greater than or equal to 15. Okay, now let's be really careful here. Okay, well, first of all, is this an and or an or? An or, right? Because you see the word or. Okay, these ones are easy to pick out. So if I want to solve this first one, because it's already split apart for me, be really, really careful here. What would I do to solve for c? Yeah, that's a positive 9. So to get rid of a positive 9, we would subtract 9 from both sides. Now when I do that, I still have a negative c left. So it's going to be negative c is less than or equal to negative 7. Talked about this yesterday. I don't want negative c. How do you get rid of the negative in front of the c? Divide by negative 1. And when I divide by a negative 1, you got to flip the sign. So it's going to be c is greater than or equal to 7. Or, let's do the other one. Okay, for this one to solve for c, I divide by negative 3, but if I divide both sides by a negative 3, you gotta flip the sign. So it'd be c is less than or equal to negative 5. Okay, so that's your answer. But then to graph this, remember, if I just say, okay, you need to be on Central or Tyler, you could be on anywhere on Central, you could be anywhere on Tyler. So the solution to this inequality is any number greater than 7, greater than or equal to, so a closed dot, greater than or equal to 7, all of those numbers work, okay? Or any number less than or equal to 5. Make sure you put the numbers in the right order, okay? Any of those numbers work. The only numbers that don't work would be these numbers here in the middle. These numbers here in the middle, you could try to plug them into both inequalities. They're not going to work for either one. Okay? Questions on number 1 or number 2? Okay, number 3. 3 is less than 2p minus 3 is less than or equal to 11. Okay, is this an and or an or? This is an and because it's squashed together. So the first thing you want to do with an and, break it apart. Okay? The first inequality, you're going to ignore that right-hand inequality and the number to the right of it. So the first inequality is 3 is less than 2p minus 3. The second inequality, ignore that left-hand inequality sign and the number to the left of it. That 2p minus 3 is less than or equal to 11. That's the second inequality. Now, all of the combined inequalities, I think they're maybe a little bit more complicated, mainly just because you split them up. When you solve both of them, you're going to use the same steps to solve both, which is kind of nice. So if I add 3 to both sides, 3 plus 3 would be 6, is less than 2p. And then divide by 2, we should have 3 is less than p. Remember, we want to, it's easier to graph if I flip it around, so we can say p is greater than 3. And then notice, like I said, we're going to use the same steps to solve the second one. Notice I'm going to add 3 first, and we have 2p is less than or equal to 14. And then just like the first one, we're going to divide by 2. We have p is less than or equal to 7. And remember, this one's going to have the word and in between. And remember the and ones, if you're on Central and Tyler, it's just the parts that are on both Central and Tyler, right? The intersection. So when you graph this one, okay, we can go ahead and mark our 3 and mark our 7. At 3, we'll have an open dot. At 7, we'll have a closed dot. Now, the numbers greater than 3 would be shaded to the right. The numbers less than or equal to 7 would be shaded to the left. Where are the numbers that are both greater than 3 and less than or equal to 7? Yeah, in the middle. And what you guys are going to find out is most of the time, the and inequalities are going to be shaded in between the dots. Not all of the time. There are a few exceptions. But most of the time, that's what they're going to look like. They're going to be shaded in the middle. Okay? Number 4, negative 4x plus 3 is less than or equal to negative 5. Or negative 4x plus 3 is greater than or equal to 11. Okay, is this an and or an or? An or, right? Because we see the word or. So, our two-step inequality here, if I subtract 3, we have negative 4x is less than or equal to negative 8. When I divide by negative 4, you got to flip the sign so it'd be a greater than or equal to 2. Or, this one we're actually going to go through the same steps again. Got lucky on that one. So if I subtract 3, we have negative 4x is greater than or equal to 8. Divide by negative 4. Negative 4. What do you got to do? Flip the sign. There's your answer. Remember, an or inequality, Central or Tyler, all of Central works, all of Tyler works. So for this one, any number, and make sure you put them in the right order, right? So positive 2's over here, negative 2's over here. So any number greater than 2, greater than or equal to 2 works, or any number less than or equal to negative 2 would also work. Okay, 2 more. Okay, number 5, negative 12 is less than 3 minus 5y is less than or equal to 13. Okay, what's the first thing I need to do with this one? Do what? Yeah, I've got to split it apart. Very good. So the first inequality is negative 12 is less than 3 minus 5y. The second one is going to be the 3 minus 5y is less than or equal to 13. You're going to be kind of careful with this one. I need to get rid of the 3 first, but that's a positive 3. So I need to subtract 3. We have negative 15 is less than negative 5y. And then to get rid of the negative 5, we divide by negative 5, which means you got to flip the sign. So I'd have 3 is greater than y, but we kind of in a way have to flip the sign again because I want to write the y first. So y is less than 3. Okay, and then the second one, follow the same steps. Subtract 3, negative 5y is less than or equal to 10. Divide by a negative 5. A negative 5. Flip the sign. So we have y is greater than or equal to negative 2. All right, so we would have, make sure you put the numbers in order. All right, I've got negative 2 and 3. So negative 2 would be over here. 3 would be over here. Now at 3, we're going to have an open dot. A negative 2, since it's an equal to, we're going to have a closed dot. I want the numbers less than 3 and greater than negative 2, which kind of is we're starting to expect are the numbers in the middle. Now don't assume they're going to be the numbers in the middle. Sometimes they won't be. Okay, notice the ands are usually on the inside, the ors are usually on the outside, but don't just assume. Okay, last one, number 6. All right, 1 minus 2x is less than 7, or 1 minus 2x is greater than 7. Okay, now this one is an or, because I see the word or. Kind of like the last problem, be really careful here. To get rid of the 1, we'd have to subtract 1. I still have a negative 2x. It's going to be less than 6. To get rid of the negative 2, I divide by a negative 2. Flip the sign, so x is greater than negative 3. Or the next one, we'd also subtract 1. We'd also get negative 2x is greater than 6. We'd also divide by a negative 2. Flip the sign. And we get x is less than negative 3. Okay, now for this one, remember it's an or statement, right? Central or Tyler. All of Central, all of Tyler, okay? This one's different because both of them are at negative 3. What kind of dot will it have at negative 3? equal to's, okay? Okay, now I want to shade all the numbers greater than -3, or all the numbers less than -3. Okay, so that's what your graph looks like, which is kind of funny. It's like almost every single number in the whole world. It's almost every single number in the whole world except for -3. Yeah, this inequality, you can plug in any number you want except for -3. Won't work.